Welcome to part 4 of the Unity 2D Basics series. In this video, I'm going to talk about events and simple movement. Before we get too far, let's review the previous parts in our existing knowledge. So in the previous part of the series, we introduced a sprite. It is an example of a 2D game object, and it has two built-in components we looked at. It has a transform, a where to draw, and a sprite renderer, a what to draw component. We want to eventually get to the goal of press a button and a thing on the screen moves, which we'll get to towards the end of this video finally. So in the previous videos, we also looked at the entity component system model that Unity is based on. And we realized a sprite is a game object, therefore it is a container, an entity, and it has, again, two built-in components, transform, where to draw, and sprite renderer, what to draw. So we're going to move from where we were in the previous video into this video. The previous video, we talked about the different components we had as part of the GameObject entity. And again, our goal is to have an input system, send events to the GameObject, and manipulate the position of the GameObject. So we're going to get there, but we're going to have to deal with game logic, behavioral script code, which we'll talk about in this video. So building off the last video then, we finally have all the components we need. We have a rendering component, so that is again the built-in components of sprite, the where to draw and what to draw components. We have our input system, which we talked through adding as part of Unity 2019 and now using it in Unity 2020, where we added the extension of the input system. We set it up with some initial inputs, and then I talked a little bit about it, and we're going to talk more about it in this video as we get into looking at Unity and especially writing code. So our model then is finally this. We have our sprite game object. It is an entity. It contains three components currently: a rendering component, which talks to the rendering system, an input component, which talks to the input system, or the input system talks to it, depending on how you want to look at that, and our game logic. So our game logic will finally, when we start to write code, and especially towards the end of this video, look at information it's getting from the input component, from the input system, decide on certain things, and change then the part of the rendering component, which will talk to the rendering system. So we'll start to create this cycle where we'll take input, make a decision, change the rendering, get input, make a decision, change rendering. And this will help us finally get to that goal of pressing a button and seeing something move. So the other thing I want to mention though, is that when we write code in Unity, which we're going to get to very, very shortly, we use the programming language C#, and this is usually written in Visual Studio. We write behavioral scripts that react to events. Again, we're going to talk more about events as talking the connection between systems and components. Our messages are sent via events. But this series doesn't really talk about C# other than some basic terms I'm about to mention. So if you're not familiar with C#, I recommend sort of looking at a resource or digging a little bit more into the programming language. That's really beyond this series that's trying to just concentrate on Unity 2D basics. So I'm going to talk a little bit about some data types and some terms, and I'll try to describe and explain them as they come up within these videos. But again, these videos are not really focused on C# as a programming language. I'll talk about it a little bit, but not really go into it as in-depth as I would like. So some common terms, though, that I'm going to talk about quite a lot as we go forward is a class, which can be thought of as a blueprint for a future object. So we create a class that defines a future object. And objects, as part of object-oriented programming, have two key things. They have properties, which are values that are part of the class and therefore part of a future object, and they have methods. Methods are functions that are part of an object. Methods are also, as part of object-oriented programming, how objects relate to each other. They talk to each other via their methods. So this changed a little bit in Unity. Unity, again, is not based on object-oriented programming. Instead, it's based on the entity component system model, which means that behavioral scripts, instead of being an object as they would be in object-oriented programming, are instead receivers of events and allow code, part of that game object, to react through their methods. So the thing to remember if you're used to object-oriented programming, which is again a part of C#, is that the behavioral scripts are not entities, they are components on those entities. And this will be important as we move into more code here very shortly. So again, components, not entities. Again, Unity is using the entity component system model. It's not based on object-oriented programming, which can be a little bit confusing if people are used to that model and are coming in with that mindset. We need to sort of break ourselves from that mindset. Behavioral scripts are game logic. They are components that are part of an entity. The game object is the entity itself. So let's actually put that into play. I'll move over to Unity and then we'll come back to these slides momentarily. So moving over to Unity, we see again we have our new sprite and it has its existing components. Transform, which again is the where to draw, sprite renderer, the what to draw, and our player input, part of the input system we're currently using, will serve as the connection between our input component to the input system. And we set all this up in previous videos. So finally then, we ended the previous video by creating a new behavioral script down here as a component. Again, a component, not the game object itself. I'm going to say this multiple times because it helps us just to remember that this is a component and not the game object itself. So we created a new behavioral script right here, and it is a component on this game object. And it created this new file, new behavioral script, which I'll click on right here. So I've already opened this in Visual Studio. So I'm going to move over to Visual Studio just to save us some time. I pre-opened it. And it looks like this. So again, it is a class, so a future object, a public class called new behavioral script. Notice it matches the name of the file and it inherits from mono behavior. So again, I'm not going to talk a lot about object-oriented programming or how C# works. But this inheritance as part of the object-oriented programming model means we get everything mono behavior has. So notice too that if you're used to spelling in the United States, that mono behavior is spelled with a U as part of the English or international spelling and not the United States spelling. So make sure if you're writing mono behavior, you stick that extra U in there. So okay, we have a class, again, a future object based on an existing class, mono behavior, which is part of the Unity engine. So we get a number of different things as part of that. Two of the things we get are two existing methods. Again, methods are how objects communicate to each other. Notice we have comments here. It says start is called before the first frame update. Update is called once per frame. This is part of what is known as the order of execution within Unity. Systems run in a very specific scheduled way. One system runs, the next system runs, the next system runs, the next system runs, and they run in a series of fixed schedules. The very first thing that happens when a scene is started within Unity is the initialization system happens. This means that anything that have start methods will be called first. So this again will be called the first frame update. So before rendering happens, start will be called. In fact, let's move back to the slides and we'll talk about this order and then we'll come back and edit some code here. So moving back to the slides, we see again default methods and their ordering. Again, this is part of order of execution. This will be important as we start talking about future videos. So again, order of execution just simply means that systems run in a very fixed schedule. One runs, the next run, the next one, the next one. And again, systems talk to components, and components are inside game objects, what Unity calls entities. So we get two methods automatically that are just given whenever we create default code. This is start, which is part of the initialization system. So before any of the other systems start, there is initialization. So it lets us get things started. And then we have update, which is part of game logic. We also have the ability to add more methods, and this will become incredibly important as we progress through this video. We will be adding more methods. Something to always keep in mind is that behavioral scripts, the code we're writing, the game logic we're writing, is not the game object itself. It is a component of it. So this means that as the entity, the game object, is receiving events via systems into components, we can listen for all of these. We have access to all of them, and then we can react in different ways. So One of the ways we can react initially is we can use part of debugging, and this is going to be something you're going to see me commonly use as we move forward, because we want to get debugging as part of our development process. We want to write code and test our code. Write code and test our code is a pattern we want to get into. So debugging is an important part of development. One of the most common tools in Unity is a method called Debug.Log, which I'm about to use in just a moment. So we can use this to see messages in the console window in the Unity editor. So you may be asking, what is the console window? Let's move back to Unity and then we will finally start writing some code. So in Unity, previously in videos, I talked about over here on the left, the hierarchy view. We have our list of entities, our game objects. We have this in the middle, which are our systems when it's running, when it's not running our scene and when it's running our game. And then over here we have the inspector view, which shows the components of whatever we have selected as a game object or asset within the project view. Currently, I have something selected in the project view, so it's showing its components right here, just more information about it. I also have the option right here of clicking on console. Console just shows anything that are errors or warnings or log messages. So when we use the method debug.log as part of Unity, it shows up a message here in the Unity editor. So we can run our code and then have messages appear in the editor as part of our testing or our debugging. Let's do that now. So I'm going to move back to Visual Studio. And when I have Visual Studio pulled up, we are going to go ahead and call debug.log. Just say hi. Now notice as I typed, it put these little squiggly marks underneath it. So if you're used to using other Microsoft products, like maybe Microsoft Word or Excel or anything like that, you notice the little red squiggly marks are telling you there's an error happening. And it marked that until I completed a valid statement here or a valid line of code. So my line 10 is now completely valid, and I'm calling debug.log and sending it the message hi. So I'm going to go ahead and save this file. So there are two ways to go about doing this. We could either go File, Save, or in this case, save this error here, or notice the keyboard shortcut Control S. So if you were on a Mac, this would be Command S. So I'm going to, in the future, be using the keyboard shortcut. So Control S to save. I'm used to using those, and it also helps to just save a little bit of time by using those. So we've now changed this code right here and said, okay, before the very first frame, as part of the initialization system, so before any other systems run, the initialization, show us the debug log hi message in the console as part of the start method of this component within this game object. Okay, let's move back to Unity. So as we move back to Unity then, what we finally want to do is we want to run this scene. We want to actually put these systems into play. So over here in the middle, at the top of the middle, we see play, pause, and over here step. And if we had some things set up, we could step through a scene as well. So I'm currently looking at the scene view, but when I click the play button, it will switch to the game view as soon as it runs and show us the current camera as well as everything within this current scene. So we have our, right here, sprite, our what to draw, and where is it draw? Well, it's where we dragged it during the scene. We also have a message in the console. So let's jump over here to console and we see hi right here from debug log it says, and we have the message hi. Fantastic. That's exactly what we wanted to see. So I'm going to stop this by clicking play again, and it will move us back to the scene view from the game view. So notice we could only access the game view while the scene was running. So we ran the scene, we looked at our debug messages, then we stopped the scene. So let's move back to our code, except this time I'm going to, right here, copy and paste. So I'm going to use the keyboard shortcuts of Control X to cut, which again, if you were using Mac, would be Command X, and Control V to paste, or Command V on a Mac. I'm also going to save this file. So as I mentioned previously, I'm going to use Control S to save. So now this time, instead of the debug log being written during the start, during the initialization, I want it run during the game logic. And I'm doing this for a very particular reason. So let's move back to the Unity editor. And notice we still have console messages, so we have options here. If we want, we could clear these, but anytime we start a scene again, it will automatically clear the console for us. So we'll just use that right now and click play. Now when it starts, we're going to see something very interesting. Notice how it's continuously logging high as a message over and over and over and over and over and over and over again. So I'm going to stop it now. So what's happening? What's happening is anytime the game logic, that is, as part of the game object was being called, part of that update method, it was logging a message. So it was doing it again and again and again and again and again. And in fact, down here it says, notice it did it 999 plus times. So I'm going to go ahead and clear this just so we don't have to deal with those. So again, what was happening? The initialization of all game objects happened first, again, before all systems. That was the start method of our game object using our behavioral script. Then, when the different systems were running, one after another, it was running the game logic system, which means it was running the update method of our behavioral script and was showing the message, 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 showing the message. So again and again and again and again and again. So again, all the systems are running in a cycle and they run in a fixed schedule. This one, then this one, then this one, then this one. And anytime it came around to the game logic system, it was running our update method. So, okay, let's build on this a little bit more because we want to finally get to our goal of press a button and something moves. So let's move back to the slides and talk a little bit more about what we have as access to the classes and as part of mono behavior. So, okay. As components themselves, again, behavioral scripts are components, not the game objects themselves, but they have access to a property called GameObject. Notice the lowercase g, uppercase O. This is a property representing the game object the component is a part of. And so we sort of get that for free. So remember, we're in a component and we want more information about other components. Well, we can do that through accessing first the game object we have as a property, and then other components. So because transform is a component that is part of all game objects, Unity has helped us out here and said, okay, well, transform is actually a property of GameObject. So if we want to move a game object, that is, change its position or rotation, we can access transform as a property of GameObject and then use its methods to do something. So we're a little bit closer to the way we want, but there's one more key thing we want. We're using InputSystem. So to listen for InputSystem events, again, think about events as messages between the systems into the components as part of the game object. So to listen for InputSystem events, we must also add using unityengine.InputSystem. Let's go do that right now, and then we'll come back and then we'll add some more code. So in our code, we need to add one more thing. We're using InputSystem, which is not automatically added to this code. So we want to say, hey, we're using the unityengine.InputSystem, semicolon. And I'm going to Control S, save this. Now notice I haven't changed anything else yet. I've just added that. So let's move right back to the slides and then we'll finally get back to writing code. So we've now added that. So this will add the C# events to our project and allow us to use them in our code, which is what we want. Once added, we can then access any of our defined events. So if you're not familiar with defined events, I talked about them very briefly in a previous video. So let's go look at them as part of InputSystem. We'll write some code and then we'll start to move things around. So, okay, let's go back to Unity. we're in the Unity editor. I'm going to select, or make sure it's selected, the sprite game object. Over here in the hierarchy view, move over to the inspector view to look at its components. Down here in the player input, which is the input system component, I see down here behavior will send message to GameObject, and then it lists everything it will send. So included in this list are things like OnMove, OnLook, OnFire, OnNavigate. What in the world do these mean? These are all the named events that we can have a message or an event trigger on, which is to say, we've decided these are the events that will happen, and then when they happen, we want to react to them. So we may ask ourselves, where are these defined at? Where do we get to them? They are part of the file we created as part of the component example input action asset. That's a lot of words together, but what I mean is, in a previous video down here, when we first added player input as part of the input system, it said create actions right here. So we created this file down here, component example.input actions, and then, if everyone remembers, we dragged and dropped this from the project view into the inspector view and associated our input actions with our player input as part of our input system. Lots of words there. So that means that if we double click this right here, we have our defined or our named actions as part of our input system component that talks to the input system. In other words, we can define our own events that will happen to our code based on sets of input actions. So our sets right here are move, look, and fire. Remember when I just mentioned it said send events, and then in that list was on move, on look, and on fire. Move as an action is associated with all those things, look all those, and fire all those. And in future videos, we will actually start to write our own custom events to deal with certain input actions we want, which is to say, we're going to set up some different button combinations that when used together will trigger different events, and then we will react to them. So move is activated on if a gamepad is connected and the left stick is moved, or somebody presses W, A, S, or D on the keyboard, or if using an XR, so during VR or AR events, a controller is detected and its primary 2D access is detected, or if there's a joystick and its stick is moved. So if any of these four things happen, an event will be generated as part of the input system, and a OnMove event will be generated. So if the input system detects any of these four things, if the left stick on the gamepad, WASD, or on the XR controller primary 2D access, or the stick on a joystick is moved or input generated in any way, the OnMove event will be called. I'm going to click on it right here. So the action type is a value, control type is a vector2. Now, I'm not going to go too deep into what a vector2 is, other than to say it's a set of two values, an X and a Y value. One of the most common usages within Unity is actually as a position in 2D space. So think of X position and a Y position. In this case, though, it's actually going to be the X and the Y corresponding to the input. So think of it as WASD. So W as up, A as left, S as down, and D as to the right. So we have up, left, down, right. So in a vector2 space, that would be 0, 1, 0 on the X, 1 as up, and corresponding 0, 1 for every other WASD, or if you prefer left stick, moving in toward either the positive space, X and Y is positive, and X negative, Y positive space, or corresponding all of that. All of that is to say that with a left stick or WASD or an axis, we're always dealing with either 0 or 1 in either value. So X or Y will be either 0 or 1 depending on which direction we're corresponding to. But the actions we are looking at right now is move. Okay, so I'm going to close this and we're going to move back to our code. So now we're finally going to add some new events. Remember, this is not the game object itself, but a component, which means it can receive all events the game object does. So we're going to write a new event. And I'm going to call this public void. And I'm going to start typing something. And Visual Studio is going to get a little bit confused with me because it doesn't understand what this event is. And it's going to say, hey, do you mean on animator move? And I don't. So I'm going to click away for just a second, then click back and finish writing this method and then close it like that. So we have public void on move. So we know then as part of the input system that when any of those things occurred I talked about, if the left stick is moved, if WASD is moved, or if XR controller is moved, it will generate an on event or an on move event. So what we want then is I'm going to move this right here, again using Control X and Control V to paste, and then Control S to save. So we added input system, and again we're going to come back and use this in just a few minutes. And we're using onMove, which is a method we added, a public void method we added. So I'm going to move back to Unity. And now finally, I'm going to play this scene. So when any of the input actions happen as part of this scene, it will do something interesting. It will show us, and I'm going to go ahead and click on the console window. Hi. Hi. I was pressing W, A, S, and D, and it was showing us hi as part of Debug Log. Notice we didn't have to specify which key was pressed, only that on move was happening. This is a major thing as part of the input system that was added again as part of Unity 2019 and we're now using in Unity 2020. This is extremely convenient. It's a little bit annoying to set up, but it is extremely convenient because we can now group inputs together. And we can say, hey, when any of these things happen, this is the event I want to happen. So we said again, when W, A, S, or D was pressed, or when the left stick was moved, or when the XR controller's axis was moved, or if a joystick was moved. So any of those things generated the on-move event. And in fact, although it's hard to see in this video, if I pick up a controller and also move its joystick, it would also register the same events. So again, when any of those things happen, this event gets triggered. So I'm now going to stop this scene, and we're going to finally move into the last part of this video. So I just talked previously that all game objects have access to the transform component, or the transform property, which is part of the transform component. So what we want to happen now is we want to take the values given to us as a vector2 from the input system to our input component. When the onMove event happens, we want to take that value, get that vector2 information, and then translate our game object. Finally, we are getting to our goal of using an input system to detect input using the values from that input to move a thing on a screen. So a whole lot of concepts at play here. Let's move back to our code and finally do this. So moving back to Visual Studio, we want to change our arguments right here. And we want to change this to input action, and I'm going to call this value. So again, when an input action happens, which again are part of that set of things, so when W, A, S, or D is pressed, when a joystick is moved, etc., etc. So okay, what we want then is because we don't always know what kind of values will come out of an input action. We use the more generic data type var. So var v is equal to value, and we want to get these. So get right here, and the kind of thing we want is a vector 2, and we'll stop it right there. So what we want then is I've written this a little bit weird. It's like, what are you talking about? So we want get and oops, moving this around a little bit. Oh, I'm sorry, input action, not input action, input value. I was like, I wrote that wrong. This is an input value. There it is. So even I type things wrong. I was like, this is not right. That's why it was getting really confused, because it's like, I don't know what you're talking about. So to rewind a little bit, we don't want to input action. We want to input value. That was my mistake. So OnMove is the action. Input value is the thing we get. Even I get confused on my terms sometimes. So, okay. OnMove is the input action. The action generates a value. So the input action generates an input value. That's what we have here as value. And again, what I was telling was still true. We don't know what its data type is. So we say, okay, more generic var is so v, we create this. We say, okay, from value, get, and then get a vector 2 out of it. And this corresponds to what we have set up in input actions, that little thing that popped up, and I clicked on move. So let's jump back real quick so I can review that. So in the Unity editor, when I was looking at the project view, and I had this pulled up right here. So we have move, action type, value. That's what I had right there. Control type is a vector 2. So the thing it generates is a vector 2. And we'll close this and move back to the code. So, okay, finally we have the input value. We say, okay, from the value, get, convert to a vector 2, get it back to us. So finally, all game objects have access to, or yes, now I'm getting confused. All components, or all game objects have a transform component. When we add a game logic, a behavioral script component to a game object, we can access the game object through GameObject lowercase g. So GameObject, and then its transform, and then translate. So translate accepts a number of different things, but we're going to hand it a new vector 3 where v.x and v.y, and it's going to assume the last thing is 0. So what we've written here is we say, okay, anytime an input action on move happens, which again is all that set of possible inputs, generate an input value. From that input value, get its exact values, in this case a vector 2, and then we want to translate working on the transform component of the game object. So in other words, move the game object around corresponding to whatever numbers you get from the input value. Finally then, whenever we press a button, it will move corresponding to the values it gets from the OnMove event. Again, number of different complicated concepts going on here. I'm going to save this file, Control S. Let's move back to the Unity editor. So move back here, we want to finally play the scene. And if everything is done correctly, what should happen is when I press D, we move to the right. When I press A, we move to the left. When I press S, we move down. W moves us up. If I pick up the controller again, if I press down, we move down, right, left, up, S, A, W, D. We have finally moved to the point of pressing a button and having a thing happen on a screen. We needed to cover, though, all of the different concepts at play to get us to this point. I'm going to finally stop playing this scene. So let me go over everything I've talked about in this video one last time, and then this video will finally be over. So, in the previous videos, we've talked about the entity component system model. Systems move in a very specific schedule in Unity. The very first thing that happens, though, is initialization. It's the very first system that runs, technically. If we have a start method as part of our code, it will start anything up, which we saw when we saw a single high as part of the debug log. The update method, which we also get as part of our code, is run during the GameObject system. So again, these move in very specific ways in a fixed schedule. We saw when we added the input system, so using Unity editor.InputSystem, we could start to add our own events. One of the events generated is part of the new input system, which we're using as part of Unity 2020, which allows us to create named events during certain input actions. And again, I went over all the input actions multiple times in this video. Whenever an input action happens, it generates an input value. So we can listen for our very specific named events, in this case, move. So when an OnMove happens, when a move is happening somewhere, we can say, okay, move is happening, give me the input value. From the input value, we get whatever it produces. In the case of move, a vector 2, an x and a y. Then we can use, as part of the behavioral script, the GameObject, lowercase g, and its property transform, corresponding to the transform component, and then access its methods, and then in this case we use translate. So all together, moving in the very specific system schedules as part of Unity, we wrote code where whenever the input system happens, if any input is being generated as part of the things it's looking for, any of the move stuff, it generates an OnMove event, passes it an input value. We look at, as part of that move through the system, we look at that input value, we get out its vector 2 information, and then we move we change our rendering components information, which then when the rendering system comes back around, then it changes it on the screen. This comes back all the way to the loop we generated, and I will pull that up one last time as I close it out, where we are finally now, the input system generates a thing, our input component talks to it, talks to the game logic, which talks to the rendering component, changing its transform values, which talks to the rendering system and changes on the screen. Input happens, game logic makes a decision, rendering gets changed, rendering system gets updated. Input system happens, input component translates that into game logic makes a decision, talks to the rendering component, changes it in the rendering system. We have finally made it to this step, working through this entire cycle and using throughout this the entity component system model that Unity uses, and now finally writing code based on those events to translate the different information we get, the different events we get, and now interacting with different components. As we move into the future videos, we'll start to compound this with even more components. Moving in the future videos then, we will start to build this again and again. We will have multiple components dealing with multiple systems, dealing with multiple values as part of the game logic, and making more complex decisions, but still existing within this model and using all of the concepts I've covered in all of the previous videos. This was a longer video, but thank you for sticking around to the end, and thanks for watching.